Hi, I'm here to call the function. I'm afraid I'm gonna need to see some ID. I didn't have to last time. Well, what can I say? API has changed. Okay, here you go. That's not an ID, that's a pen. So you can't use this? Nope. If I did, it would throw this error.
Bonk.
Oh, okay. How about this? I know, that's not an ID. How about this? Okay, good deal. Contract reached. All right, why are you being so paranoid? I'm not being paranoid, I'm being defensive. Okay, why are you being defensive? So you don't f up my runtime. Okay? Okay. Man, these intros are getting out of control. I know. Today we're going to talk about defensive programming, or as I'd like to call it, code like someone will definitely misuse your function. Because they will. But since that's too long for a video title coming from a guy who called his thing this, let's just call it defensive programming. Because they will use your function the wrong way, and that someone might even be you in 3 weeks or 3 months or on a Friday afternoon. This is 25 things JavaScript developers should know but probably don't. This is episode 21, defensive programming. There's not gonna be any animations or storytelling in this one, just 10 to 20 minutes of pure live coding. What could go wrong? Let's write some extremely safe code, yo. Or something a little more exciting. Defensive programming is more of a mindset than anything else, and it really goes back to the very early days of software engineering and programming, especially in mission-critical systems like aerospace and military and banking and medical, where if you had a bug, it was a huge deal. It would mean a lost satellite or $1 million or even loss of life. Like, that's not really crazy to think about when you consider medical systems. It does happen. This is the face I make when I think about all the things that could go wrong with my code.
Bonk.
Today we're going to talk about defensive programming. Shut the f up. So what is defensive programming? It's like writing code with a helmet on. It's like an insurance policy. It's about anticipating what could go wrong before it does go wrong, guarding against it before it blows up your runtime. I'm gonna show you 10 scenarios where we're gonna add defensiveness to our code, make it a little safer and a little less prone to error. But again, it's important to remember defensive programming is more of a mindset than any single thing I can show you today. So all this stuff that I'm gonna techniques or tricks I might show you today, it's not an exhaustive list. It is not a definitive list. These are just some of the examples of what you can do. And these are obviously specific to JavaScript. In different languages, it might be even a little different. So you don't just learn defensive programming. These are here to inspire you. And with that, let's get started. Number 1, fail fast to the browser. What do I mean by that? So fail fast here, all this means is that, let's say I have a function called getUser, and it does a bunch of things. I didn't write the code for you, I just left some comments here. Let's say we log the access, we check the cache, we send some analytics, and we finally fetch the user like this, based on the ID that came into the function, right? I'm just gonna comment it out because that's not a real API and my tool is not gonna like it. What is this tool, you may ask? This is something called Run.js, and Run.js recently just added this, which is the color code theme. So if you get Run.js, you can write code that looks and feels exactly like mine. So what's wrong with this function? So if I don't pass in an ID and I end up doing a bunch of work, like all this, logging and caching and whatnot, I know right away if the ID doesn't exist that I can't do any of this, or rather I can't do any of this well. I can't do them right. The only thing that might actually break is this fetch function, right? Not gonna work. So what I can do instead is before I do any of this, I can check to see if ID doesn't exist, right, I can either break out of this or I can write some kind of error message. There we go. We can say, hey, ID is required. So if I don't pass in an ID, now I'm gonna get this error. So I won't be doing any of this. I'm gonna save a bunch of compute time. I'm gonna save myself from polluting the logs and the monitors. But if I do pass in an ID, then it goes all the way through, it passes this check, and I get to my log and I do the actual log. So that's number one. Failing early means, fewer mysterious bugs later in my logs and caches and all the other things. Number two, check for type, not just for truthy. So what we're checking for here is truthy. We're making sure that ID exists. Instead of that, what we can do is something slightly more intelligent. I'm gonna use a different function so you get a variety of examples here. But let's say, similar idea, we have a getLength function. I can do this for you, look at that. GetLength, and it takes a string, and if string is falsy, then we're gonna return 0. So for example, if I say getLength, length, and I pass in Sina, I get 4. If I pass in null, I get 0. If I pass in a number, I get undefined. So it's not doing exactly what I want it to do. I mean, it's a nice little check, but it doesn't guard against everything. So let's pass in 3 different examples. An array is going to be 0, 0, but then the 1, 2, 3, again, if I pass in a number, it doesn't know what to do with itself. Instead, what I can do is I can actually check for a string type. If it's string, then we do what we need to do. If it's not a string, then we're going to say, hey, I'm sorry, a string is expected. Let me comment this out. With a Boolean, we're going to get the same thing. With a number, we're also going to get the same thing. But if I pass in a string, Sina, it's going to give me 4. So don't just check if it exists, also check that it's the right thing. Now you might be thinking, wait a minute, Sina, I don't need to do any of this. I have TypeScript. It does all the type checking for me. Well, guess what? Oli, TypeScript is a compile time tool. And that means once your code is transpiled and compiled and it's running in production, you no longer have all the checks of TypeScript. In fact, it is just pure plain JavaScript. And JavaScript cannot and does not enforce any types, not at runtime. So if your input is coming from an external source like a user input or an API response, TypeScript is no longer there to help you. It can't protect you, so you have to do the runtime check yourself. But now, why should we throw an error? Why is throwing an error better than just being silent and passing maybe 0 in this function? Well, an error is going to be a lot more explicit. It's going to tell you what exactly went wrong. If your error handling is graceful and detailed, it's going to tell you where it happened. It can tell the consumer what kind of input was necessary, so they'll know to go back and fix it. Debugging becomes a little easier. We had fail fast, and we want to fail loud, so we know exactly what happened. It makes your code a little bit more self-documenting, as in if I read this code, by reading it, I can almost already tell what it does. And if I could summarize all these benefits into one, is that a clear intentional error is better than a silent, confusing crash any day. Okay, so moving on, what we just did was we verified that the input was there and it was the right type. But we could take this one step further. We can sanitize and validate the input also before we verify it. So for example, let me get rid of all this. Let's say we have a function that parses the age of a person and you pass in an age string. So for example, if I have parse age, 10, it returns 10. But what if I pass in Sina? It gives me none. What if I pass in, let's see, what if I do like null? 0. What if I pass in something even crazier, -10? That's not good. No one's ever going to be -10, except for all the JavaScript babies that are going to be born in 10 years. All right, so I'm going to replace this function with something a little more interesting, a little more thoughtful. So what parse age does is first it numberifies the age string that came in. So we turn it into a number. Then we're going to check to see if the thing that came in can actually be a number. So you saw if I pass in, I think if I pass in one of these, that's actually going to be a none. And then if I pass in something that is negative, it's also an invalid age. So we're saying, hey, listen, that's not a valid age, give me a valid one. So what we're doing here, it kind of is we're sanitizing the data before we do stuff with it. And if we realize that after sanitization that we can't, we validate the input and we realize it's no good, then we kind of move on. Or actually we throw an error and we say, we're not gonna process your request. Pause, water time. Oh yeah. All right, number 4 is defaults for the win, baby. All right, defaults came to JavaScript a few years ago, several years ago now. So let's say I have a function called greet, and I want to uppercase it. So if I call greet and say, enough of Sina, let's do qoli. Okay, so that works fine. But then what if I don't pass in anything, right? I have a type error, so I have a runtime thing, and now everybody's freaking out. Even worse, if I do 1, 2, 3, it says name.uppercase is not a function, and this is a problem. So we're gonna do something else with that. The problem that I'm about to solve isn't actually going to solve the 1, 2, 3 problem, but if I have a default called, I don't know, stranger, if I don't pass in anything, I'll get hello stranger, which is very cool. That means if I still pass in stuff, it will work. And if I don't pass in anything, for example, we don't know who the user is, our greet message that, let's say we want to show up at we want to render at the very top of the screen, it still works. It just doesn't, it's not specific to the user. And that's because maybe we don't have the user's name yet. So that's kind of nice. The problem of 1, 2, 3 is actually not going to be solved by this, obviously. That's a type problem that we now know how to solve with the previous example. So how is this different from the other 1, 2, and 3? Number 1, we said, you didn't give me anything. Number 2, we said, you gave me the wrong type, I'm out. Number 3, we said, what you gave me is shady or bad input, I can't deal with that. And here, number 4, what we're saying is, you forgot to give me an input altogether. But no worries, I got you. I can just say hello stranger. All right, moving on to number 5, guard against structure changes. You might have heard of optional chaining. And here we're saying use optional chaining like it owes you money. So I have a function here called getCity. What getCity does, I'm gonna get rid of this, is it takes a user object, then looks at the address inside the user and then the city inside the address. Which means if I do this, well, let me give you the best case scenario first. Here's the good case, is that user address city Milano. Now what happens if we don't have city inside our address, right? What's gonna happen is undefined, and we don't like that. We could do better than this, guys. We can do what's called optional chaining. So I can check the user has address, then I can say, does address have city? And if none of those are available, I can say unknown or something like that. In real world applications, you often use data. You work with data that comes from some API, or you might be connecting to a CMS or some other external service that's out of your control. These structure changes happen all the time where people are just gonna give you a different version of the data or just not gonna give you enough data. You know, fields disappear, things get moved. A lot of assumptions can break. This kind of checking guards against that. And if you do this, you make sure your app doesn't crash, especially when the source of that data is out of your control and it's not yours. It's one thing if you have a backend person next door, you can just knock on their door and say, hey, what's going on here? But again, a lot of times you're getting data from places that aren't in your control. So, optional chaining, my friends, take a look at that. Number 6, avoid side effect surprises. Does anybody remember this one? I have an example that I used in episode 20. Let's say I have an array of numbers, 1, 2, 3. I'm gonna assign my arrays to that and your arrays to that. So let's say we both of us really like these numbers. And so we do that, and then we say, you know, we want a function that would add an item to not cart, let's say array. So array, and then we do that, and we do that. So it takes an array and it takes an item and adds that item to that array. So let's say now I wanna add stuff to add item to my array. What do I wanna add? Number 4, because I like 4 too. So this happens and we think everything is fine, except your array is also 1, 2, 3, 4. So why is this a problem? The problem is that I changed my thing, but JavaScript ended up mutating your array as well. So what we can do instead of this is I can return a whole new array that does ... array, I believe, and then item. Yeah. So this is your array down here. This is my array. So my array and your array are both protected, but what I received from this function is the full array of 1, 2, 3, 4. This way, you're not the developer that changed somebody else's data, which in most cases means state. Again, this goes back to the idea of immutability that I covered in episode 20. Watch it, yo, it's right here. The short version is that if you're mutating an array or an object somewhere deeply nested in thousands of files you have in your app, who the f knows where it got changed? You're gonna have to do a lot of digging to find out or debug the issue. And all of a sudden, your object or array has a bunch of things that you don't recognize. Don't do it. Copy the object, don't mutate it. Remember, if you want to change me, you have to make a copy. If you want to change me, he stood firm. You'll have to make a copy. Ha! That was episode 20. I'm telling you, you gotta watch it. It's very good. I'm very proud of it. All right, moving on. Number 7, lockdown mutable globals. If it should never change, make it unchangeable. Let's say we have a config object, const config, and let's say this object is very precious. It has a bunch of things in it that everybody's looking for and everybody is using. And let's say we don't want somebody to come in here and say config.theme equals, I don't know, dark. Joey Bag of Donuts shows up and he goes, well, I think the theme should be dark. If that's the case, if it's that the config object here is in fact precious, you can buy yourself an insurance policy. So instead of declaring it like that, we can do config is object.freeze and give it whatever properties you want. If I now do a config log here, you can see the theme did not change. Now, this was a silent failure here, but I believe if you run this in strict mode, I'm not even sure if in Run.js I can use strict. Let's see, use strict, does that work? Yeah, there we go. It says you can't assign to a property theme because this object is frozen. I didn't know you could do this in Run.js. Awesome, and this app keeps getting cooler and cooler. By the way, as a reminder, if you want to get Run.js, you can go to runjs.app/colorcode and they'll know that I sent you. It is an affiliate thing, so if you are going to pay for it, if free version isn't enough for you, if you go through that link, they will know that I sent you. So to wrap up this idea is that don't mutate a shared variable, aka state. If you want to make changes, you can return a copy, kind of like the last one I showed you. But that's, again, that's besides the point. The point with this one, number 7, is that you can protect yourself from unexpected changes from the hungover intern by freezing the object. One thing I mentioned in episode 20 is that object.freeze only works for the top level of the object, I think. So if you have deeply nested properties within that object, it's not going to protect it unless you object freeze those as well. All right, moving on to number 8, timeouts are defensive too. They're a defensive technique. For example, let's say we have an async function here that fetches a user, right? And it's not gonna work because we're not fetching anything yet. I'm gonna write a different version of this. Async function fetch with timeout. So we take a URL and we do a timeout, and I will even do a default there. Let's do that. So let's say it accepts a timeout. One thing you can do is, let me get this a little bit smaller. One thing you can do is there's something called an abort controller, a new abort controller. Thank you, Run.js. I can set a timer, set timeout. Some of you purists out there are gonna hate on this, but you're welcome to start your own YouTube show. I can say, let's call this controller. Controller.abort after the timeout. Can I make this smaller so it all fits? It still won't fit. Let's do one of these. I don't like it, but I'm trying to give you clarity. And now I'm gonna return fetch, but I have my data, URL. We're getting a little bit into the weeds of the implementation details for how you use the abort controller, but give me a second, I will explain everything. That finally, whoops, daisy. clear timeout. Timer. All right, I'm gonna clean this up for us and then we can talk about it. I don't know, that's probably as good as it gets. Okay, so what we're saying here is if you call fetch with timeout, we'll take a URL, we also take a timeout, but if you don't give us anything, we're gonna assume 3 seconds is enough. So we're gonna create an abort controller, which we will later pass to the fetch API. And we're gonna say, look, we're gonna create a timer, and that timer is going to have whatever amount of time we pass into the function. Again, we assume nothing is gonna get passed in, so 3 seconds. And we'll say as soon as the 3 seconds is done, if my timer is still running, abort the mission. And that is what abort controller does. You can probably read of the documentation on that a little bit more. So what we're gonna do is we're gonna call fetch, and the fetch, we're gonna take the URL that came into the function, we're gonna call it. You can pass in a secondary parameter to fetch to say, these are some of the configurations I want you to handle. Signal is going to let our abort controller know whether or not that call was successful. And then once we're done, we're gonna clear the timeout and say either we don't need it anymore or that it was the reason why we aborted the call and that we should clear it. We should always clear timeouts after ourselves. So the idea here is that even the best servers sometimes have a hiccup. So why is this timeout helpful? In this case, you're not protecting against bad input, you're protecting against the lack of response. So if in 3 seconds, if my fetch doesn't get a response, it's automatically going to resolve itself. Timeouts are a defensive boundary. It's a way of saying if the server doesn't respond, I'm not gonna wait here forever. This is especially relevant for network calls. I mean, I think of that as the primary, maybe the only reason to use this. I'm sure someone can think of a reason why other than network calls this is important, but this is especially in my eyes important for network calls where the delay is out of your control. You don't know how long this is going to take, and you don't want to freeze your entire app for an unknown amount of time. Although this is async, so it's not really freezing the app, but you want to know if something is taking more than 3 seconds, you want to show some kind of error state, or you want to react to that so the user knows, well, they're not waiting forever. You might want to give them the option to retry and all the good UXy stuff all of you wonderful babies can think of. So the bigger point here is that defensive programming doesn't just protect your logic, it also can protect your time and eventually the user experience. One other thing about timeouts and protecting time, and we're getting into the boundaries and the territory of user experience. Timeouts and debounce as a technique always go together. This is not a tutorial about how to use timeouts. It's the idea of making sure something happens to your app after a certain amount of time. But think about debounce as well. It's kind of a similar technique in making sure that time is spent wisely and that your app isn't abused in any way. I probably should have added another example for debounce, but hey, guess what? Uncle Cena's tired right now, so look into timeouts on your own. Next one, number 9. Number 9 is wrap dangerous code inside something. And by wrap, I don't mean the wrap. I mean wrap. We're talking about dangerous code in this one. The question is, what is dangerous code? And that is, well, there's plenty of things that are dangerous. It could be your own code, but in this case, we're talking mostly about the code that you didn't write, but you're going to run. What do I mean by that? For example, parsing JSON. You never know what JSON you are parsing if it's coming from an external source. So that's a really good example. I am going to copy paste this function. Let's say I have parse JSON. You get a string and you want to parse it. If this isn't, I'm going to bump this up a bit for you. If this is something that you're just going to run and the JSON itself is coming from your, this does not have to be, by the way, a network call. This could be you're reading from your local disk. You never know if that JSON is going to be valid. So I can easily break this. I can just say not valid JSON, right? And that's gonna happen, or I'm also going to do this. There we go. So if it's a string, it's just gonna break. It's a syntax error, and right away our app is blown up. So what do we do about this? We can, first of all, we can put this inside a try catch. We can say, if the thing didn't work, just do nothing. Wait, that is the wrong name. Bam. Or maybe we should call it safe JSON. Safe JSON. It says, all right, well, nothing happened. This is better than nothing. This is better than blowing up the app like we had it before, right? So if I don't have this try catch, what did happen? It was saying, well, I don't recognize this, the curly, and your JSON is bad, the position 1 line, blah, blah, blah. You don't want to do that. Let's bring these back in. At least this doesn't break. But we can take this a step further. We can actually give ourselves a little error message. I said error kind of like Oprah. We can say failed to parse JSON, unexpected property name, or blah, blah. So at least you see the error. If you really want to know where in the JSON there was an issue, sometimes that's useful, but it didn't cause a crash. It didn't cause a runtime error. So if you're going to risk it, if you're going to run some JSON that you haven't seen before dynamically from some file system or some API response, then you might as well wear a helmet. So this one is not about validation or types. It's about runtime volatility. This is a very volatile environment in production. You're saying this code might explode. I'm gonna catch it before it brings down the entire system. Some of you might have heard this is called the containment strategy. It's a defensive strategy. It tries to isolate any danger that you might be running within this. And in other words, making the blast radius of the problem be within just that one function and not the whole runtime. So defensive programming means you don't just trust those things, you catch them. And last but not least, number 10 is enumerate the unexpected. So let's say we have a function that handles the status, and then it updates the UI to show the status. So loading indicators and error states and whatnot. One way to do it is to just assume the status that came into the function is one of the known statuses that we have. The statuses could be success, pending, error, failed, whatever. But if someone puts in handle status banana, I'm assuming your UI doesn't know how to handle that. Well, this error is actually something else. It's saying we don't have update UI. But if we had update UI, let's say it had, maybe you had a class or style that you wanted to append to your container so that you could show different colors based on the status. Banana is not a status. So how do we do this? We can enumerate this. Let me get rid of this. I actually have a switch statement here so I don't have to type it. I know it's pretty miserable watching me type sometimes because I make a lot of mistakes. And a bunch of you also don't like how I treat my keyboard, how I press really hard. I don't know if I press that hard. So anyway, we're saying, look, these are the statuses that we know, that we are aware of. Success, pending, failed. And if all of those, if it's one of those you give me, I'm gonna update the UI, I'm gonna pass the status there. Or let's say these were, like I said, classes. I can append those to my elements. But if you give me something that I'm not aware of, if it's not one of the three that I know, I'm going to throw an error and say unknown status, which is banana, right? And this way we can also log things, monitor things for remote logging and make sure we capture it. This one is solid. Now there's debates whether you should use a switch statement or something else. That implementation detail aside, you want to be explicitly handling all the cases that you know are not going to work. So again, this is another one of those fail loudly type of handling that are especially useful when you're working with backend responses, some feature flag situations I can think of where this is a problem. Any other scenario where you have enum-like values, this is going to be really helpful. Another sort of philosophical thing about defensive programming is it isn't just about preventing crashes. It's also about preventing wrong behavior from kind of slipping through the cracks if you don't have enough checks and balances in your code. And those are hopefully giving you some idea of what we mean when we say defensive programming. It's not about paranoia. It's about respecting the runtime. Is that a thing? You respect the runtime. But it is respect for your time as a developer, for everybody else as a developer who works on the same code base, and most importantly for your users. You want the sanity of the users to be kept alive. You want them to know when something breaks. You want to give them real explicit errors. Not just the end user, but also the consumers of your function or your API. A lot of what I showed you today is useful in backend code. I don't normally go into backend programming because it's not my area of expertise, but so much of this defensive programming applies 100% to writing backend code as well. So next time you're writing a function, ask yourself, how could this break? What are some of the possibilities that a consumer, including myself in 6 months, could use this function for and misuse it, whether intentionally, in a lot of cases, unintentionally? All right, I hope that was helpful. This was episode 21 of 25 things JavaScript developers should know, but probably don't. Next episode is, I think, on JavaScript proxies. Hell yeah, I had a lot of requests for that, so we'll see if we can make that happen. And don't forget, defensive programming is not about paranoia. It's a mentality meant to protect your weekend. See you next time.